And the last technique we're going to learn to make our network a little bit faster is scheduling the learning rate. So we talked about what learning rate is in the previous modules, but just to recap, learning rate determines how far or how big of a step to take when we're doing the gradient descent step. So once we've decided which direction to go, learning rate determines how far in that direction we should go. So when we have our gradient vector that we talked about before, we multiply it with the learning rate to determine the distance that we're supposed to go. So the learning rate is actually quite critical in terms of finding the optima that we're looking for. In this case, this white area or this dip or like the lowest point in the curve that we have in terms of the relationship between the parameter and the error. So on the left side, you're seeing what it would look like if we only had one parameter. On the right side, you're seeing what it would look like if we had two parameters, and we were able to see kind of like a 3D version of the relationship between the parameters we have and the error. So what happens is, if your learning rate is very small, you're going to keep taking smaller and smaller, you're going to just keep taking small steps towards the minima that you're looking for. And in a big space where the optimum is really far, it is going to take a long time for us to make our way into the optimum that we're looking for. And that is a problem because this is going to take a very long time to train and converge our neural network to the point where it is performing reasonably. So another problem that we might have is to determine a very high learning rate. And in that case, what's going to happen is that maybe we are going in this correct direction, but we are going to keep overshooting the optimum that we're looking for in terms of cost or error. So in a 1D graph, it would look like constantly going left and right and not being able to capture the minimum point. Or on a more three-dimensional point, it could be that, yes, we make really good progress, even if we are very far, we're going to make really good progress to the area where the cost is very low, but we're going to keep overshooting it, but we'll never be able to really capture the point where the cost is very low. So the solution to this has been to basically schedule your learning rate and lower it in time. So while you're training, you start with a relatively higher number and then you lower it and lower it. But there are also some other approaches to this. So let's look into some of the learning rate scheduling approaches and how they work. The first thing that you can do is to manually try learning rates. If you have the computational power, if you have the resources that you need for this, you can just start training your model with a lower learning rate, and then you exponentially increase your learning rate and try and train a new model. And at the point where you see that your validation loss starts shooting up, then you know, okay, I need to choose something that was a learning rate that was a bit before than the one that caused the validation loss to start shooting up. So that is one way, but of course it's very hands-on and it's very labor intensive in a way. But you can also just schedule your learning rate to increase or decrease at a certain rate. So one way to do that is using power scheduling. Power scheduling basically makes the learning rate a function or determines the learning rate based on a function on the number of epochs that you're on right now. It introduces a couple new parameters that need to be learned, but that's generally not a big problem. And what happens is basically you decrease the learning rate as you go further in the training process, but you decrease the rate of the decrease of the learning rate. So it gets smaller, but at the same time, the rate at which it gets smaller also gets smaller. Next one is exponential scheduling. It is kind of the same idea. It's still, the learning rate is still a function of the epoch, but now it doesn't get smaller in a smaller rate. It basically drops by a factor of 10 every S epoch. So S is a hyperparameter that you would need to determine when you're starting this learning rate scheduling. Then you have piecewise constant scheduling. That one is very simple. You just basically determine what the learning rate should be in every epoch or every number of epoch ranges. So you can say the first, it should start with 0.1, and then after 10 epochs, it should be 0.001, and after 20 epochs, it needs to be 0.00001, for example. So that's kind of predetermined piecewise scheduling of the learning rate. Next one is performance scheduling. This one is kind of common sense in a way. You are connecting the learning rate to the performance. So you're starting the learning rate on the higher side. So you're making bigger steps towards the minima. But after a while, when you see that the validation error does not lower anymore, does not decrease anymore, then you can make the learning rate a little bit smaller. So depending on the performance, if you cannot make any progress anymore, if your program or if your model sees that it cannot make any progress anymore in terms of validation loss, it's going to try on a smaller learning rate. The last one is called the one cycle scheduling, and this is one of the most interesting ones also. What you do is, instead of decreasing your learning rate all the time, at first you start with a very low learning rate, and then step by step you increase it slowly to what is called the optimal learning rate, so N1 here. And then in the second half of the training, you again slowly decrease it back to N0. So N1 is called the optimal learning rate, and that is determined by the manual approach, basically. Trying learning rates, trying to see which one gives us the best results, and trying and seeing when loss stops or when does loss start shooting up, and then choosing the learning rate that gave us the results that is right before the validation loss started shooting up. So that you use as the optimal learning rate, and you multiply it by 10, then you have your initial learning rate. And starting from that one, you slowly build your way up to the optimal learning rate, and then the second half of the training, you go back to the initial learning rate. So of course there has been some research into which one is the best and which ones work better than the other ones in terms of learning rate scheduling, and the results for now, the most commonly used ones and commonly accepted to be the better ones are exponential scheduling, performance scheduling, and one cycle scheduling. So if you want to do learning rate scheduling, you can give priority to those ones and see if they work for you, but I would also approach just trying out the other ones to see how they would work for you. So with that was the last technique that we have to make our models or networks a little bit faster, help them train faster. If you have any questions, again, don't forget to comment them below this video, and I'll see you in the next video.